Hi, everyone. Welcome back to another episode of Ask Dr. Nick. My name is Dr. Nick Schmidlkoffer, and I work for the Neurologic Wellness Institute here in downtown Chicago. And today's episode is going to be based on pain. So the question of the day is, why do we experience pain? Pain is something that is essential to our life, especially as we evolved as humans, because we need to be alerted. Pain is basically an alert to our brain to say, hey, something is wrong, whether that is we have damage to our tissues, we have possible impending damage later, maybe we have inflammation that could lead to death, anything. And so pain is essential to us to live, but it should only alert us about danger, and it shouldn't keep causing pain in the future. It is an alert signal that is present when there, and then goes away when the problem or the root cause is taken away. And so we're going to talk today a little bit about the pain pathway, and then why we can have pain that happens, and then later on that leads to chronic pain, when really there really is no like damage or impeding insult that is still occurring at the site of pain. Okay, so I want to tell just a quick story here, or more just a quick instance, and that would be if you are walking in the woods and you're stepping on twigs and all this stuff, and it just seems pretty natural, and maybe one twig feels a little bit sharper than another, and you just keep going and you're not really too worried. Yeah, it hurt slightly, but you're fine. You just keep going. Then what happens is later on you get to the point where you want to stop, you sit down, and all of a sudden you realize that you have a nail in your foot. And now that slight pain also becomes very painful. Well, why wasn't it an issue earlier when you first stepped on it? Versus now when you see the nail. And that's where our emotional aspect comes in. Pain is not just coming from the site of injury. Pain is involved more in the brain. And so at the site of injury, that just kind of causes an insult. But we don't have pain until that signal reaches the brain. And so pain is not just a physical insult, it's also an emotional biopsychosocial insult. And so when we see that we have a nail, now we have this throbbing pain, and now we're going through like, oh, is this nail rusted, or is this causing more danger, right? So now, let's say you get the nail taken care of, everything's good. A couple months later, you say, okay, I'm gonna go back and walk through the woods, and you're stepping on twigs, and all of a sudden, like, every time you step on twigs, now it's like, oh, was that a nail? Did that feel like a nail? Or you're constantly worried and perseverating over this possibility that you could have a nail in your foot. And this is an essential thing that your brain should feel. It should feel a little bit worried, because heck, that nail in your foot the first time could have been leading to some impending doom, for whether that be your foot, your leg, or maybe your entire body. And so your brain should be a little bit hyper aware of that. And that's where a pain stimulus that doesn't necessarily get taken care of should be a good alert signal. We really want to get to that root cause so that then we don't ever have this chronic pain developing. Okay, so first I want to show you just a very good book that I would suggest everybody that has had pain or is in chronic pain to look up and read. It's a relatively easy read. It's written for the lay people or lay person, and so it's called Explain Pain. It's by David Butler and Lorimer Moseley, and both of these they're from Australia or New Zealand, and they do a great job of explaining why we experience pain and all the different nuances that are involved with chronic pain or with pain that's more acute. And it's just a very, very good and easy read, easy book. Now we'll go right into this. So this is a pain pathway. I just like this diagram because I think the guy is kind of funny. And so kind of like that example of stepping on a nail. So if we see that when we step on a nail, there's a receptor. This is the site of injury. The receptor is picked up through two different types of fibers, a fast, a delta fiber, and then a slow C fiber. And that pain travels up, or that signal, I should say, the signal, the nociception, the cause of damage, that signal travels up the nerve in your leg, the sciatic nerve, and gets into the spinal cord. And at the spinal cord, there is a synapse. That's basically a transfer of this signal, like, hey, something's going on down here. And then that crosses in the spinal cord and then goes up through the spinal cord into the next section, which is the brainstem. And through the brainstem, it then gets up into the cerebrum, or the more bigger part of the brain, cerebral cortex, where it may talk to the thalamus, talk to the limbic system, which is involved in emotions, and the somatosensory cortex, which allows us to distinguish, like, yeah, I stepped on a nail right on the ball of my foot. It was that one sharp point. This is why a lot of times that we have this connection between, yes, there's this one sharp point, but then now my emotion can get involved. So every time that we get pain, we're kind of activating this emotional limbic system part of the brain that can then lead to anxiousness or anxiety about the pain, or it can lead to a poor mood state, sadness, anger, whatever that may be. So along this pathway, besides the initial, like we're talking about, there's actually pain because I stepped on a nail, people can have pain people can have pain due to a problem at the site of injury within the nerve. Let's say there's a nerve entrapment because of muscles or other things that are causing entrapment. There can be a problem at the spinal cord level, or the nerve root, where maybe there's a herniated disc and hitting onto the root causing pain, whether that pain is here in the back or down in the foot. There can be problems in the transmission through the spinal cord up into the brain. And then there can also be problems in these different areas, whether that be the actual cortex, the somatosensory cortex, causing issues of pain when really there's no stimulus down here, but there's still pain. Someone is still experiencing pain. Or even, again, there's no stimulus down here, but we have so much anxiety and fear avoidance that we're going to get injured, we're going to have pain, that this limbic system is driving more and more pain and causing that pain to spread. So I want to go to just an article here that is a Nature review, and it's the cognitive and emotional control of pain and its disruption in chronic pain. And so basically they talk about how chronic pain is one of the most prevalent health problems in the world. We have back pain, we have headaches, we have arthritis. Many mind-body therapies like yoga and meditation have been shown to help, which means that maybe cognitive emotional control can be beneficial for chronic pain. And then, modulation of those areas in the brain. And then, so chronic pain itself is altering brain circuitry. And therefore, by altering brain circuitry, that can lead to this further chronicity and make it harder to overcome. So here, let's just talk real quick about the definition. Pain is a complex sensory and emotional experience. I like to think of it as a biopsychosocial. So it involves a biological system, the actual insult. It involves the psychology, or how we think about the pain. And it also involves social factors, like if I have pain, I can't actually go out into the world and enjoy my life with my friends and family. Our emotional state has an enormous influence on the pain, in which a negative emotional state increases pain, positive one lowers pain. So we'll kind of talk about that. Let's go down to, here it is, So we know that emotion can positively affect cognition and back and forth. It can also negatively affect cognition. When we're really frustrated, maybe we don't think right. We know that cognition can affect pain, and pain can negatively affect cognition. Emotion can do the same thing. So there's all these feedback loops going on in our brain. So here are the main, when we went back to that pain pathway, so this is that pain pathway coming up, and it doesn't only go to those couple areas I mentioned, it goes to multiple areas. It goes to areas in the brainstem, it goes to the cerebellum, it goes to the amygdala, which is part of the limbic system, so that we can maybe have fear of doing something that previously was painful. It goes to the insula and the anterior cingulate cortex, which are both involved in the limbic system and involved in that emotional response to pain. Here it goes to the somatosensory cortex, so we can actually feel the exact location of the pain. And then it also talks to the prefrontal cortex, which is involved in the our cognition and what we should maybe be doing next about the pain. So that's just an important look at how the brain is so involved in pain processing. And so then we look at this picture, and this shows that if we modulate attention towards our pain, so basically we're either distracted from pain or we attend to the pain. And when people attend to the pain, we have a significant difference of pain score than when we're distracted from the pain, which is pretty interesting. But at the same time, it doesn't affect unpleasantness as significantly. Now, emotional modulation, if we have an increased intensity here, a bad mood or a good mood does not really change it much. But a bad mood causes increased pain for the unpleasantness aspect of it versus the intensity. While a good mood will kind of make us more pleasantly involved with the pain, if that makes sense. And so here we have some different regions that are involved in those aspects. So in the green, we have the emotional aspects that are involved to decrease this unpleasantness. And so the anterior cingulate cortex, the prefrontal cortex, this is the periaqueductal gray in the brainstem that's involved in descending inhibitory pain pathway, or basically inhibiting the upstream effects of that stimulus that may be causing pain. And so when we activate these areas, get ourselves in a good mood, that can actually decrease that pain processing, and therefore we can have a better, pleasant attitude towards the pain. On the other hand, we have a couple other areas that can be more related to the cognitive part, or the attention that is activating the circuitry to basically decrease that pain intensity. And so by activating areas in the cortex, which may be getting too much information, or maybe getting this like cortical smudging that, we had pain in our hand, but now it's in our wrist and our forearm as well, because the brain doesn't really know exactly where the pain is. If we activate this area or other areas involved in the insula, the amygdala, we can actually improve and decrease the intensity of the pain. And then here, I just like this one too, is as chronic pain develops, there are three main areas that constantly show problems when looking at imaging studies and other studies. And so basically decreased opioid receptors. So opioid drugs are generally to decrease pain at the brain level. But we have endogenous opioids that we produce when we exercise. And when there's chronic pain, we actually have this receptor desensitization, where opioids don't work on these three areas that can be involved in decreasing our pain perception. At the same time, inflammation is very possible in these two areas, the prefrontal cortex, the anterior cingulate cortex. And the FA is basically showing that there's like white matter changes. So there's poor synaptic connections in these areas as well. So to summarize, we experience pain because it is necessary to alert us of danger, but we don't want that pain to continually to happen. And so, let's say you have an injury in your foot. and that injury should heal within 4 to 6 weeks, depending on what it is. There's no more inflammation, there's no more pain in the foot, but maybe you still experience pain. Where is that pain coming from? Is it still in the foot, or is it from a different region in the brain that's not properly processing the signals in the foot? And so that's where we come in to really help activate those regions and give your brain a better sense of where you are in space and how you can work with experiencing your body as is versus having pain. We get to the root of the problem, whether that is in the foot or in the nerve or in the spinal cord, in the brainstem, or higher up in the brain. And so I really wanted to talk about this one because we see a lot of people dealing with chronic pain, whether that is from concussions or dysautonomia or just chronic pain from accidents that never healed. And so I think it's a really valuable talk. And like I said, that book is a really good book to just read and just really get a good feeling of why you actually experience pain and how you can deal with it maybe on your own. So if you have any questions, I would love to answer them. If you have any suggestions for future topics, please leave them below. Thank you for tuning in today, and please stay healthy.